Some of the concepts that I have already explained you the random variables that are functions of sample spaces. So I have explained you sample space. Then very important topic or concept is the probability mass function, okay, and the cumulative distribution function. So we just talk about the probability distribution function, which is actually PDF. So PDF give you a value of a particular function, okay, at a particular point. Okay, so f is equal to 1. So this is your probability distribution function is. For 1 it will have a value, for 2 it will have a value, for 3 it will have a value, for 4 it will have a value. What CDF does, CDF is cumulative distribution function. It gives you the probability of that or less than that. Okay, so for example, if we have 5% here, we have 6% here, we have 6% here again, and we have, let's say, 7% here again. Okay, so what we'll do, we will add 5 plus 6 plus 6 plus 7. Okay, so so for first one is 5%. For the this is PDF, this is CDF. Okay, for CDF, for 2 is actually 11%. We will add 5 and 6. Then for 3, the CDF will be 17%, and for the 4, CDF will be 24%. Okay, so cumulative, as it is, representing the name also, in the cumulative function we try calculate x. X is the capital CDF is less than or equal to x. Okay, so for the probability of 3 as an event is 6%, but which is probability distribution, but the cumulative probability of 3, which means 3 or less, is 17%. It will definitely be higher than that. Okay, so I have already explained you the discrete random variable where the numbers are 1, 2, 3, 4, 5. Then we have continuous. I give you an example of rain expectation, which is 60%. Then we have quantile functions. Okay, so quantile function is we have this sort of distribution. So what we try to calculate is we try to, in the quantile function, we try to separate a part of it. For example, we try to separate the first 30% of the distribution. Okay, so quantile, for example, we want to check the first 50% and second 50%. Okay, so the example of quantiles is actually quartile where we want to see 25%, 50%, 75%, and 100%. You will be seeing quartile in your result also. I explained it how FRM actually uses quartile to rate you. Then you have deciles. Okay, so deciles by mean 10, 20, 30, 40, and 50, 60, 70, 80, 90, 100. Then you have percentiles. Okay, so percentile, you can give any percentage for the quantile calculation. So it can be 12 percentile. Okay, yeah, 13 percentile. So it can be any percentile, and all of these are referred as quantiles. Then we have a concept of moments. Okay, so moments is basically gives you an idea about the distribution, how the distribution is, how it reacts, how you should be able to, for example, if you know that COVID-19 is normally distributed, you may be interested in knowing the average number of expected numbers of deaths or expected number of cases in a particular country. So what you will do, you will use the expected or mean function of the normal distribution and will calculate the expected deaths or expected morbidity for any particular country using the normal distribution function. Okay, so we have 4 moments basically. If this is a basic formula. Okay, so what we do, x is any observation. So we have a series. Okay, so 3, 4, 10, 11, whatever it is, and this is called x. Then we have mu. Mu is the average of it. Okay, so we add all of this divided by the number of observations, and we will get our mu for discrete numbers. For continuous different, we'll discuss this later. Okay, so for example is 3, okay, is 4, so 4 4 4 4, and then you will have your distribution as x minus mu. So you will minus this minus this minus this minus this, you will get a series. You will basically take that to this power. So if it's mean, you will just keep it 1. If it's variance, you will square it. If it's skewness, you will triple it. If it's ketosis, you will give it to a power 4. Okay, so these movements will give you 4 things: mean, variance, skewness, and ketosis. Okay, so ketosis and skewness we will discuss in our chapters later. It is a detailed study there, but skewness is actually a measure of symmetry. Okay, so for example, you have this, either you are skewed towards the right, either your distribution is skewed towards the right. So yeah, so this is this, so this is normal. Okay, just a minute. So this is normal distribution. A positive skew distribution would be something like this. Okay, and a normal negatively skewed distribution would be something like this. Then you have ketosis. So ketosis basically determine the height of the distribution. So you have normal distribution. A ketosis would be like a higher ketosis would be like this. This is very bad actually. Let me just draw it again. So something like this. Okay, so you will have fat tails problem if there is a high ketosis and so on and so forth. So then CDF also corresponds to the distribution function where we use calculate. We'll discuss it later. Then we have the stochastic variable. This is again another name of random variable, where random variable is determined by the outcome of the random experiment. So random variables are also referred as stochastic variables. Then I think I have explained all of these things. That will just be a mere repetition. So a single variable or univariate probability distribution I have already explained you. Multivariate I have already explained in chapter 1. Bernoulli is one of the type of the distribution where the sample is 0 or 1. For example, a client will default or it will not default. So if it will not default, it will be 0. If it will default, it will be 1. Okay. Binomial distribution is also a distribution that we use for the same purpose. So these are discrete distribution. That is something that we'll discuss further in detail when we'll move forward. Expectation is again the mu, the mean. So we calculate by the weighted average in the probabilities. Then, as I earlier explained, expectation is actually the mean, the arithmetic mean, which is calculated using x minus mu. For the discrete, it is using through this, but for the continuous variable, it is used using this integration formula of x into fx. Okay, so we'll discuss this later than when we'll read it. But for calculating a mean of a discrete random variable, you will be simple multiplying the probability with the outcome, and we'll be adding it up to get the mean. But for calculating the mean of a continuous probability, we'll be using the regression equation, and we'll actually won't be probably be doing the regression. We'll be using it. We use it to calculate the mean of a continuous random variable. Then a variance, we will just see it when we will calculate it, but variances actually give you a variation from mean. Variance is variation from mean. So what we try to do, we try to this is the actual observation and this is the mean. Okay, so we calculate the series for all of the variables and then we square it. Okay, and then we add it, then it will give me the variation from the mean. So for example, if the mean is 4, okay, and all of the variables like 4.1, 4.2, 3.9, 3.8, 4.5, 4.6, 3.5. So it will have a low variance because all of the observations are between 3.5 to 4.5 or 4.6. Okay, but if we have a variable like 4 but observation mean like 4 but observation like 10, 1, -1, 15, -5, the variance of this series will be high because it is varying at a larger distance from the mean. Okay, so obviously when we are calculating return, we try to estimate our return, mean return. Okay, and then we see that what is our variation, how volatile our returns are, and then we decide on our distribution on our risk calculations. Okay, so this is it. Then we if we take under root of it, it becomes a standard deviation. A standard deviation is or if we take a square of a standard deviation, it becomes variance. Okay, so this is a relationship that you will have to read by heart. It is just, it also give volatility is just a advanced measure, or a different measure to calculate the same volatility, but at a different level.